So in a previous video, we showed what an equation was and what it meant to solve an equation. In this video, we're focused on the practical side of solving an equation. And it will start out pretty basic, but even if you know this stuff already, I think it's still valuable to see the main ideas very explicitly shown in terms of how we actually solve an equation. Students often make mistakes about notation and what exactly they're doing. And so this video hopefully will show how we actually solve equations on a pretty detailed level. The first main idea behind solving equations is that we can perform any operation on both sides of an equation and the equation's truth value will remain unchanged. What do we mean by this? Well, let's take an example. The equation 8 equals 8. We can perform any operation to both sides of this equation and the truth value of the equation will remain unchanged. That is, the equation will still be true. For instance, if we multiply both sides by 2, we still have a true equation. If we divide both sides by 4, we still have a true equation. If we subtract both sides, subtract 1 from both sides, we still have a true equation. And similarly, it works with expressions. Suppose that x equals 15 is true. If we multiply both sides by 2, 2x equals 30 is also a true equation. If we divide both sides by 4, 1/2 x is equal to 7.5 is true. If we subtract 1 from both sides, then 1/2 of x minus 1 is equal to 6.5 is true. As long as we perform the operation on both sides, then we have a true equation from beginning to end. So if the first equation is true and we perform the operation on both sides, the next equation is true, and so on, and so on. The second main idea when it comes to solving equations is that we want to perform inverse operations until the variable is isolated. Inverse operations on both sides of the equation. Now, as a really simple example, we have x plus 2 is equal to 5. Now, this is going to be really detailed, and even if you know how to do it, it might be worth paying attention. We subtract 2 from both sides of the equation, and I'm rewriting it, but instead of the usual canceling out line that you might see in high school especially, or junior high, I'm writing the equation out. In the circle on the left, we have plus 2 minus 2, and that transforms into 0, while on the right, 5 minus 2 transforms into 3. We can simplify this even further by eliminating the 0, because anything plus 0 is merely itself. So we're left with x equals 3. This is actually the full work of solving the equation. I think sometimes when students write a minus 2 and cross things out, it makes things a little unclear as to what exactly we are doing. This actually shows the new expressions after we subtract 2 from both sides, and that's why I think it's valuable to see it this way. So the same thing when it comes to subtracting 3 from x. We perform the inverse operation, which is adding 3. Then we rewrite the expression. We group the numbers together. On the left we have it equals 0 because they're inverses. And on the right we have 9 plus 3 is equal to 12. We get rid of the 0 and we have x is equal to 12. For our third situation, we have x, the variable, being multiplied by a number, in this case 3. We perform the inverse operation, which is to be divided by 3. Another way of rewriting this is using fraction notation. So we have 3x divided by 3 is equal to 12 divided by 3. Now, I'm going to make the inverse step here extremely explicit, just in case you don't see it. 3x over 3 can be rewritten as 3 over 3 times x. The 3 over 3, of course, is equal to 1, and the 12 over 3 is equal to 4. And it is in expectation that we'll be able to simplify 3 over 3 into 1, and that's why we divide in the first place. So on the left side, we have 3 over 3, or whatever the case will be, we'll always simplify to a 1. And we can get rid of the 1 because anything times 1 is itself, and we have x is equal to 4. The last step is we have x divided by 5 is equal to 4. We multiply both sides by 5. And I found that students often get confused as to what this means because, unlike the other ones, the way that the notation is written on the page does not instantly suggest that we're canceling out anything. In fact, often students, especially on a basic level, will show have this equal x over 25 is equal to 20, which certainly isn't true. really what we have here is we multiply the entire fraction, x divided by 5, and we get 5x over 5 is equal to 4 times 5. Again, we rewrite this fraction as to show 5 over 5 in the fraction over here. 5 over 5 simplifies to 1. 4 times 5 simplifies to 20. We get rid of the 1, and we have x is equal to 20. So this is basically a summary of the 4 most basic types of equations. Some textbooks refer to these as one-step equations. In the next video, we're going to show slightly more complicated equations that involve 2 steps, and we're going to show why we have to do them in a particular order. But the main idea here is that we have to perform the inverse operation on both sides until the variable is all by itself.